Okay, so what I'd like to do is just some review of geometry. So there are two theorems that come in handy, the 45-45-90 theorem and the 30-60-90 theorem, and I'm going to derive them here for you. Hopefully you remember them. And then we'll do a couple examples. So let me just do a black pen. So the 45-45-90 theorem comes out of a square. So if you start with a square and all the sides are x, and all the angles are 90, then if you slice the square with one diagonal, then you've created two 45-degree angles. And you can use the Pythagorean theorem to solve for this missing side. So x squared plus x squared equals the question mark squared. And you get 2x squared equals the question mark squared. So then when you take the square root, you get plus or minus the square root of 2x squared, and then the x squared can come out as a single x, so you get x root 2. And since it's a length, we're going to ignore the negative one, so it's just positive x root 2. Right, so this right here is x root 2. And then really what you can do is you can forget about all the rest of this. So the 45-45-90 theorem says if you've got a triangle with two 45s and a 90, then the two congruent sides are going to be x, and then the hypotenuse is going to be x root 2. So that's really all you need for that theorem. The 30-60-90 theorem comes out of an equilateral triangle. And if you remember, equilateral triangles also imply that all the angles are the same at 60, 60, 60. And what I'm going to do is I'm going to make these sides not x, but 2x. And when I slice my triangle right down the middle here with an altitude, then this 2x gets cut into an x, and then I can do Pythag again to figure out what that missing altitude is. So x squared plus question mark squared equals 2x all squared. And so this is going to be x squared plus question mark squared equals 4x squared. So question mark squared is going to be 3x squared. Then you take the square root, and you get plus or minus root 3x squared, which turns into x root 3 with a plus or minus. But really, since it's a length, we're just looking at x root 3. So now I can say, okay, this thing right down the middle, x root 3. And if I get rid of this, then here's the real theorem here. Right? And now this angle up at the top is only 30. Okay. So these are the two theorems that we need. And now I'm going to take you through a couple example problems, and then you're going to do a bunch like these. So in the first problem, it says find the, for both of these examples, it says find the missing sides of the triangles, then find the coordinate of point P. So in this problem, it's 210 degrees all the way around to this segment from the origin to P. And since it's 180 degrees on top, the bottom part's going to be 30 degrees. So we've got a 30-60-90 triangle. And in a 30-60-90 triangle, the hypotenuse is the 2x side. The side opposite the 30 is the x side, so this ends up being 5. And then the missing side is the x root 3 side here, so this one's going to be 5 root 3. Okay, that means that point P is going to be at negative 5 root 3 and negative 5 for the x and the y, because you got to go backwards 5 root 3 and then down 5. Okay. If we look at the next one, it's 315 degrees all the way around. Since the whole way around is 360, then this has to be 45 degrees here. And so this is also 45. So now we got a 45-45-90 triangle, and the two congruent sides are this one and this one. So this has to be a 9. And then the hypotenuse here is, if we scroll back up, it's x, x, and x root 2. So it's 9, 9, and 9 root 2 right there. Okay, so hopefully that makes sense. And then go ahead and try the 4A handout, and it's all a bunch of problems just like this. Oh yeah, one more thing. We need the point P. That's going to be 9 units over and 9 units down. Okay, so go ahead and try the 4A problem, see how you do. We'll talk about them tomorrow in class and extend the idea a little bit more.